Welcome to part 2 of my CNC Start to Finish series. In part 1, we designed this simple hold down clamp in Fusion 360. So we have the 3D model, but in order to actually turn this into a real part, we need to do the generate the Cam Toolpaths. So we can do all this in Fusion 360. So we did all the drawing in the model workspace. So now we want to change to manufacture. Older versions of Fusion 360 called this Cam. They've renamed it to manufacture, but it's the same thing on both. So first thing we need to do is we need to do a setup, and the setup is what sets our orientation of the part. So how it's going to be placed on the CNC table, essentially. Now, as I mentioned before, part of why I chose this design for a demo is it's got the extra challenge of we have to do things on two different sides. On this side, we have this recess. That's the recess for the head of the hold down bolt. And on the bottom, we have this lip, which is used for where we clamp down onto a part. So we need to do one setup with the part flipped like this, and then we'll do the finishing with it like this. So let's go ahead and do our first setup. So we go setup, new setup, and the first thing we need to do is define the orientation. So we've got our X, Y, and Z. So here you can see the Z is coming towards us. Z is up and down on the router, so that's not what we want. But what I usually go for, there's a couple different ways you can specify this. The option I find works easiest is select X and Y axis. So let's do that. It's asking us for the X axis, and the X axis is actually correct here. Actually, I'm going to turn it around this way just so we can see that change. So let's select this for our X, and then for the Y, we'll select this line. So now we have the X going left and right, the Y going away from us, the Z going up and down, which is what we want. Now, we need to make sure we have a way we can zero this on the machine. So by default, it chooses the top center as the origin point. We need something we can reference off of from our blank piece of stock. So let's click box point here, and you can see that it gives us options for bottom, middle, and top of any corner and along any side. So I'm going to select this lower right corner for this one, and you'll see why. Normally I use the lower left corner, but when we flip it, we'll end up using that, and you'll understand why when we do the second setup. Now the other thing we need to do is right now Fusion 360 tries to guess how much extra stock you're going to use, and by default it does 40 thousandths. It assumes you're going to cut this out of something that's 40 thousandths bigger on the side and on the top. What I prefer to do is, since we're doing this out of plywood and I need a way to clamp the piece down, I do 1 extra inch on the side, and we're going to use stock that's the same thickness of what we want to make, so we're going to set that to 0 for the stock. And you'll see that this box, the shaded box, which is the piece that we're cutting it out of, is larger. So we can click OK there. Now we need to do an operation, and for this side, the only thing we really care about is cutting this piece out here. So for that, we can do a 2D pocket. First thing we need to do is we need a tool. So right now, I'm going to assume you don't, this is your first time using this and you haven't defined any tools. I have some tools defined in my library, but it's easy enough to add one in. I'll show you how you can do that. So we're going to do all these operations with a 1/4 inch spiral router bit. So you can see we have various types of tools, and so first we want a milling tool. And so starting with these tabs, so on the first tab you can just add some general information. These are really just notes for you. You can have things like the link to where you bought it if you need to order more of them. I tend to leave those just blank. For the cutter, this is the important stuff that you do need to define. So we need the type of a cutter, and we're using a flat-ended end mill. It's a 2 flute, and these it's less critical to enter these, but I'm going to go ahead and do this. It's a carbide, no coolant, and here's the important stuff is the actual diameters and sizes. So we're doing a 1/4 inch, which is 0.25 inches. I'm not so worried about the shoulder length, but what we do care about is the flute length, and this is a 1-inch cutter. And the other lengths are less critical here. You can use those to help define if you're, going to cut too deeply. But we know we're only doing 3/4 inch plywood. We have a 1-inch cutter, so all of that is good. The other thing that is useful on these tabs is the feed and speeds. You can define these when you actually use the tool, but here we can set some defaults. Now, Fusion 360 does some really useful things where especially if you have a spindle where you can control the speed of the spindle through the CNC software, you can specify what speed you want it, and you can tell it how much of a bite you want it to take for each tooth, and it'll actually calculate these feed rates. I'm using a normal router, so I don't have any control over it, and it's really, for doing just a simple router, you're best off just setting the feed rates. And what I find works well, and this is something you really need to experiment with your setup and see what works well, but 80 inches per minute for this cutter tends to work fairly well. So we'll do, and we have cutting, lead in, lead out. I'm going to leave those the same. The ramp by default is different, but when you're ramping in, it is good to move it a little bit slower, so I'm going to set that at 60. And once again, you can experiment with these and see what works well for you. But that's all we need to do to define a tool. And you can see here now we have this 1/4 inch. It gave it tool number 1, 1/4 inch flat, and it gives some of the details on it. So we can click OK, and you see that that's the tool we're using here. Also, all those feeds and speeds it'll set those values in here. So if you wanted to override them for a certain operation, when you use a tool, you can define that here. So now it needs to know what are we going to cut. So we're doing a 2D pocket, and so we just need to define the area that we're cutting. So in this case, all we care about is cutting this little lip area here. So we can select that, and it knows that's where we want to cut. For the heights, this isn't too critical, but it just shows us, what we have is, first of all, we have a bottom height, which is the bottom of the cut. In this case, it's not going to really show up on the diagram here because it's just selected contours, and we selected this, so this is going to be the bottom. The top height, the top of the area you're cutting, is just equal to the stock top. The feed height, which is where it's going to begin ramping in, is going to be another 2/10 of an inch or 200 thousandths above that. The retract height, which probably should be actually what we want to do, is we want to do this from the feed height. So retract, meaning when it's going to move, it's going to pull it up to that height, and you can see the line there. And then the clearance height, which is when it does larger moves, and it's a little difficult to understand exactly when it does the retract height and the clearance height. It really comes down to how far it's moving, but you set this a little bit higher yet so that you can clear things like other clamps that are holding down the stock. Now, for passes, we don't really, for this one, this is a fairly shallow cut, so I'm not too worried about doing this. We can do this in one operation. It's about a 1/4 of an inch, and it's a 1/4 inch diameter tool, so we should be okay there. But if we did want to do that in multiple paths, we could use this multiple depths tab, and I'll show you that when we do the thing on the other side, so we'll leave that. Now the other thing is, by default, is trying to do a stock to leave. Now the 2D pocket and also 2D adaptive, or same thing with 3D, the adaptive and the pocket operations are not intended to be extremely precise operations. They're intended to remove the bulk of the stock, and if you're doing something where you need the part to be very precise, what you do is you leave a little bit of stock here. Here you can see it's leaving 20 thousandths of an inch, both radially, which means around the outside of the tool, and axial meaning like along the end of the tool. So it would leave a little bit of operation, and then you would do another contour operation, which is much more precise to remove just that little bit of stock that's left. We're not worried about this being that precise, so I'm going to leave that unchecked so we don't need to do that extra operation. And then on linking, about the only thing for this operation I care about changing is this 2-degree helix is a little shallow. So for plywood, I tend to make that 10 degrees. If we click OK here, you can see that it did our tool path. You can see it's going to, this blue line is when it's actually cutting, and it'll remove all the area that is this lip. So that's all we need to do for the first setup. Now, just to keep things straight, I'm going to rename this setup to be bottom, just to give it a name. And now what we need to do is we need to, so the intention is we're going to flip it upside down then and do the top side. So first of all, let's remember that our, actually if I click here, we use the lower right-hand corner for our 0 point on this operation. And we need to remember that because when we do our new setup, we need to make that be, well, first of all, we're going to flip it over. So now that corner is now over here, and I still want to do it along the bottom. So I'm going to go ahead and select that origin point right here. Now our X, Y, and Z are still not correct, so just like we did before, I'm going to select X and Y. We want this to be our X and this to be our Y. And frustratingly, it always moves the origin around. You really need to save that for later. So let's reselect our origin. Now our Z is upside down. X and Y are in the right plane, but notice how the Y is pointing towards us, not away from us. And because of that, that's causing the Z to point down as opposed to up. So to fix that, we can just do this flip Y-axis, and which move the origin again. I still find that rather frustrating, so let's move it back to where we want. But now we've got what we want. We've got X going left and right, Y pointing away from us, and Z pointing straight up. The other thing we need to make sure is consistent across our two setups is the amount of side offs that we had. So we had 1 inch before, we still need that now, and we're going to do 0 on the top. Now, I didn't talk much about why I chose the bottom corner rather than the top corner, and different people prefer to do this different ways. I've found that this works better for me. What I can do is I can zero out my Z height on the router as being right at the table, and then when I do the cutout, I know, even if I haven't measured the thickness of the stock quite correctly, I know I'm not going to gouge into the table, and I'm going to cut all the way through the part properly. So that works well for me. So earlier we did a 2D contour on the bottom. We're going to do the same thing, or sorry, not contour, the 2D pocket. On this one, since we have a more complex shape, I'm going to change that to a 3D. Now, it's hard to explain exactly the difference between the 2D and 3D operations, but essentially a 2D operation is a much more simplistic algorithm for determining where you would just give it the area and the depth you want it to cut, and it essentially will just do things along one plane. What we care about here is in one operation, I want to do this recess and the inner slot. So if we do a 3D pocket, and once again, it's we want to verify we have the right tool, and we're going to do this all with that 1/4 inch end mill, so that is correct. We're not going to change any of our feeds and speeds. Now here, we do need to change it. So if we don't set any of the geometry, it's going to try to do in one operation everything it can do, which would mean removing all of the stock around the outside, that extra inch all the way around. It would mill all of that away, and it would probably try to face off the top to flatten it, which we don't need because we're already doing this out of a flat piece of plywood, and then it would do the inner part. What we care about is just that inner part. So we can go selection for the machining boundary, And we can just select this oval, and we want tool center either on or outside. If we do tool center inside boundary, it tends to not actually get the whole thing. But if we do tool center on boundary, meaning never let the tool go any farther than the center on that boundary, that should get everything we want. And we'll check the tool paths before we finish up here. Once again here on the heights, now we'll see something a little different than we saw with the 2D. On this one, it does know, it is going to show us where the bottom is, because we didn't just select a contour for it to cut. We're actually saying the bottom of, don't cut anything below this. And so any place within that area that it can cut all the way to the bottom, it will. And we're going to do the same thing for all of the other clearance heights. Except for I wanted this. Yeah, no, this is correct. And once again, for passes, we don't want to leave any stock because we don't need this to be super precise. So I'm going to uncheck that again. But now we don't want it to try to do this full depth as one cut. So I am going to go here in the passes, and we are going to say here where it says maximum roughing step down. By default, it's 40 thousandths. That's really based more on doing things in metal for these defaults. So a good guideline, especially when doing wood, and really for most things, is you never want to cut any more depth than 1 time the diameter of the tool. So this is a 1/4 inch tool. I'm going to be a little bit conservative and just do 0.2 inches for the maximum roughing step down. So that should be a pretty good, fairly conservative depth to cut. Now once again on the ramp, I'm going to change this to 10 degrees, and the rest of this should be good. So now we'll get a little more complex tool path on this because we're doing a more complex operation. So let's take a closer look at this. First of all, you can see this. You can see it helixing down. The reason it does that rather than plunging is router bits and end mills tend to cut better on the edge and don't cut really well in the center. So by doing this, you're not relying on the center of the tool to cut, because it's a router bit. It's not a drill bit. It's not really intended to just plunge straight down. So it does this circular motion to get down there, and then it does some. You can see it clearing out this upper area here. And if we flip it around to the bottom, you can see that that tool path then gets a little narrower and goes all the way to the bottom. So that looks like it's going to do what we want. But just to be sure, what we can do is we can simulate this. So the simulate button, and what we want to do is we want to turn on the stock button so we can see what it is we're cutting. And I'm actually going to turn off the tool path. But this will show us the actual operation in simulation of what it's going to do. So this is a useful thing to do. Make sure it looks like it's doing what you expected. A lot easier to fix it now than have it do something you really didn't want on the real part. And for this, we can, once we think we're happy with what it's doing, we can click this button, which will jump clear to the end. And we can see what results. We see that it did cut all the way through. That's a useful thing. Sometimes if you don't have your height set up correctly, it won't cut all the way through. But that goes all the way through, and I think everything looks good. So I think that tool path is good. So now the last thing we need to do is actually cut this out of the stock. As I mentioned, we could do something like that adaptive, that 3D adaptive would have done it, but it would have removed all of this stock. Of course, that would be a problem because we, ideally we've got this clamped down, around these outer edges. We've got something holding it down, so we can't just remove all that because we've got clamps in the way, and the part, once it broke free, it would just kind of go flying. So what we're going to do is we're going to actually cut this out, and to do that, we can do a 2D contour. And so what this is going to do, so we've got a very similar dialogue here where we verify we've got the right tool. That's correct. And now for the geometry, it's what we want it to do is we want it to tell it to cut along here along the bottom. Now, if we didn't have this notch here, we could just select this line here. However, that line does not go around the whole thing. So that's not what we're going to want. And it's 2D paths are fairly dumb. It will cut right through parts of your model if you tell it to do something like that. So instead of doing that, let's click on this oval, and that gives us the shape, but it doesn't give us the proper height or the depth of where it's going to cut down to. But we can fix that on our heights tab. The other thing we want to do is we want to make sure that when it cuts through, this piece doesn't come free. So we can tell it to leave tabs, and I have this set from a previous job. I had it set at 5 inches. This piece is much smaller than that. So if we tell it just to do every 2 inches, now for now ignore the fact that it's putting the tabs on the top. That's because we haven't set the height. But you get an idea of where it's going to put the tabs. So it's going to put 2 tabs on each side, which should be good. It is going to put one here on the nose, and when we move this line down to the bottom, obviously that's not connected to anything. So that's not really going to be useful, but these other 4 should be plenty to do this. So now on the heights, this is where we actually, before when we did a 2D operation, on our original operation, we just said, the bottom height is the selected contours. If we do that now, this isn't going to cut anything. It's literally just going to follow around above here. It's just going to be cutting air and may just be slightly rubbing against the part, and it's not going to cut anything out because this top part of the model is what we selected as our contour. So what we can do here for bottom height, instead of selected contour, we can do either model bottom or stock bottom. They're the same on this situation. So let's say model bottom, and now you can see it's moved that down. So it's going to try to do that contour. We've defined the shape on the previous screen, but now we've defined the depth here. And we're going to leave these other heights should be the same. They should be fine. Now, on passes, this is slightly different because it's a 2D. When we did the 3D and we didn't want to cut all the way through, we did it, there was like a maximum roughing step down. For the 2D operation, there's this multiple depths tab, which didn't even show up before. So if you see this, this is probably, for the operation you're doing, this is probably where you want to set how deep you want to go. So the maximum roughing step down, once again, defaults to 4,000ths of an inch. We can do much more than that. Once again, we'll do 0.2 inches, which should be fine for our 1/4 inch depth. Stock to leave is not checked, which is good. We want this to just do the full cutout. And now if we go down here to the linking, there's for the 2D contour, especially when cutting things out, one thing I like to uncheck is this lead out. If you leave this lead out checked, when it's done, it's going to try to pull the router straight away from the part wherever it happens to finish and then up. And by pulling it straight away, it's actually going to gouge in to the stock that you left around the outside of it that you didn't cut. So if we turn the lead out off, it'll just pull it straight up, which I find works much better. Also, we want to make sure we do ramp in. Now, instead of doing a helix ramp, a contour, we'll just do a ramp where it follows along the path of the contour, just down at an angle. And once again, for plywood, I find that 10 degrees is much quicker and works just fine. So now we can click OK, and we can take a look at our tool paths. So let's turn this around to where it started. First of all, you can see the ramp that I mentioned, so that's coming in at that 10-degree angle, and then it's going to follow this blue line, which is 0.2 inches from the top. So it's going to go all the way around once, and then it's going to ramp down again, go all the way around, and then finally on this bottom pass, you can see it lifting up the tool to leave these tabs. And you can see here it's trying to leave a tab that won't be connected anyway, but the other 4 tabs should be plenty for that. So once again, just to make sure things look right, I'm going to click Simulate. Now we're just simulating this 2D contour, so you won't see it do that middle part. But you can see it ramping in, going all the way around, and ramping in each time around, and I'm going to just jump straight to the end. And if we look at this from the top, you can see that it did cut all the way out, and it did leave our tabs, so that all looks good. Now, just to make this a little more obvious, I'm going to change this one to slot, just so we have a name of what it is, and we'll call this one. If you double click on it, it edits it. If you click and then wait a second, then click again, then it lets you change the name. So, and then this is the cutout operation. And I'm going to name this one bottom. And this setup, I'm going to call top. So, we should have everything we need to cut it out. What we'll do, just to quickly review, first we're going to have it flipped, let's see, this way. And it's going to remove just this portion. Then we're going to unclamp it. We're going to re-zero the tool on this point after we flip it over, which is now over here. It's the same corner. Then we're going to remove all the slot, including the countersink, and then we'll do the second operation, which cuts it out. So now what we need to do is we need to actually generate the G code that gets sent to the CNC router. So starting with the bottom, if you right click and post process, so first of all, make sure you have the appropriate processor set from this list. So there's a lot of operations here. It depends on what software you're running. Mach 3 is what I'm using. It's a fairly common one. That may be what you're using. So if so, Mach 3 Mill is what you want. I ignore the output folder. I just leave that set to whatever it is by default because I end up saving it someplace else. For the program name or number, it defaults to a number because there's some CNC machines that can only take a number because they'll display that on the screen. But what I'm going to do is I'm going to call this bottom. And we will post-process that. Now, it asks me where do I want to save it. So here you can save it to a USB stick. More than likely, I'm assuming you're using one computer for doing your CAD work where you're running Fusion 360 and another computer that actually drives the CNC. So the way I do it is I put it in a shared folder. So I'm saving that, and that's network mounted to my other system. You may want to put it on a USB stick or wherever, but that's entirely up to you. Whatever you need to do to get that file to the other CNC machine. Now, for that, there was only one tool path for that operation, so that was easy enough. For the top, where we have two separate operations, there's a couple ways we can do this. We can either post-process the setup, right click on top and generate it, and that'll generate one G code file that does all of those operations, the slot and the cutout, without stopping in between. What I prefer to do though is do these individually. That allows me, it makes it a lot easier to restart it. It means a little more work when you're running it because after the first one finishes, you do need to load the other one into your CNC program. But I find that works. It makes it much easier if I need to restart things, like if a bit breaks, for example. And so maybe I've cut all the inside out, and then in the process of doing the outer cutout, the bit breaks. Well, I don't want it to run through all this inner part again. If I replace the bit and re-zero things, I should be able to just rerun the cutout program. So I'm going to do this as two separate things, but same thing, where we do post-process, give it a name, and tell it where we want to save it. And same thing here. And that is it for this video. What I'm going to do now is in a couple days I will post a video of actually setting up and zeroing the CNC router and actually cutting the part out. So if you're interested in seeing that, and some more hopefully useful workshop and CNC related videos, definitely subscribe. And until then, hope you enjoy. Thanks.